Hello everyone, welcome to this video, and in this video I'm going to demonstrate how to get the linear regression using the Microsoft Excel. So when we say linear regression in a common words, it gives you a prediction of a certain variable, if that would be a predictor or not, and a model to show what would be the possible estimated value on it. Now, the result would be a model which is an equation which is y would be your dependent variable is equal to b sub 0, which is your constant, or the intercept, plus b sub 1, which is the numerical coefficient of your predictor, and x would be a possible input. So that would be a linear function. If you're familiar with math, which is y is equal to mx plus b, that is the model. Hello everyone. So this is now our data for our linear regression. So let's look at this one. So we have an attitude and income. So this is our set of data. So let's see how to do a linear regression. So as you can see, the income would lead us to our dependent variable, and the attitude would be our independent variable. So there are a lot of testings that happen here. However, it's very easy if we're using data analysis in Excel. So when you click now the data in the data ribbon, you click now data analysis, and then let's go to regression. So there are two things that you need to choose. The Y range would be your dependent, which is the income. And then we have our independent, which is our X value, which is the attitude. So there's a scale on it. And then click now the labels. However, there are a lot of things that you could look at, like the residuals and the fitness of line. So there will be on more advanced. However, I'm just going to click now the output range, and let's go on some basic. So I'm going to put the answer here, and then I'll click now OK. So there are a lot of data that we have here. So let me just adjust now here. So let me just adjust as well the things. However, there is some redundant data here. So these are not the things that we need. However, I'm going to highlight and make our data would going to be in two decimal places. So it's much easier for us to look at it. So let's see this one. So we have here our data in two decimal places. So let me just give you things that we have here. So this one is the multiple R, or just simply the correlation between um the two variables that we do have, the independent variable, the R square, and then we have now our significance, or our significance when it comes to our ANOVA when compared to 3. And then we have our coefficients for our model, and then we have our t-stat and our p-value. Okay, now let's have it one by one. So once again, the R is our what we call our correlation, correlation between our two variables. So there is a high relationship between attitude and income. And then the R square is our coefficient of determination. So we have now our coefficient of determination. So we will explain its utility when we know our model. Okay, determination. So we have that. So let's go on our model. Remember that our model would be, let me just look at it, on, that is the y is equal to b sub 0 plus b sub 1 x, right? So our model, that would be y hat. Let me just check if I could look at, if I could find an equation. However, I cannot put an equation. However, let me just model that. So y is equal to, as you can see, we have our intercept, and then the attitude would be your numerical coefficient for your x. So let me just have it here. So our b sub 1, or b1, that would be 7,522.79. Our rather, that's our b sub 0, rather, b0, or our constant, and b sub 1 would be 2,535.535 0.61. So when we make now our model, we could say that our model will lead us to y is equal to 7522.79 plus 2535.61x. So that is now the model. So what does it mean? This is now the prediction. When we substitute the value of the attitude, we will now determine how much would be the income of that person. So, however, how sure are we that this is good? We could say that because of our coefficient of determination. The coefficient of determination, you can put it at 83%. So that this could be determined 83%. So this is very high when it comes to the result. So if that is true, we could say that, like, let's look at this another one on significance, another way to look at it. The regression has a 0.00 significance. Remember, when you look at the test, let's go back to the data analysis. We tested at 0.05 because 5%, the default is 5%. So that's that's the default. So therefore, it is significant that there's a significant that we could there's a difference between the two. And then now we could say that the attitude is a predictor for the income. So that's how you look at now which one we have now, a product or a model. And we could say that the attitude is a predictor for the income. So that's how you look at now a linear regression. I hope you learned something about linear regression, and this could help you in determining a one variable is a predictor of a certain outcome. So I hope this video would help you. Thank you very much for watching. Have a great day.